So we're going to do a transformation from a table to a table. So this table is our function f. Notice that when I input 1 into f, it spits out 0. When I input 2 into f, it spits out -3. So this is a table showing me the relationship f of x. And what I want to do is some transformation on f of x to make g of x. So this will be transformed from there. So this is a pretty good process. I think it's fun. So first thing that my answer is going to be written like in this form right here. So g of x is some sort of transformation on f of x. Notice I have some multiplier, some vertical dilation. I have some shift in x, and I have some shift in my outputs, my y values. So as I take a look at that, first thing that I want to do is I want to find a. A is about growth, how the change, that's a delta, that's a symbol for change, the change in the growth from one table to the next. So as I take a look at this, I'm just going to look at how the outputs are growing in each of these. So in F, 2 to 9, that's a change of 7. And 9 to -2, that's a change of -11. -2 to 5, that's a change of 7. 5 to 0, -5, and I could keep looking at those. So that's how it's growing. It doesn't help me think about what f is. I don't even care about writing an equation for f. But what I want to do is compare that growth to this growth that's going on down here. So 1 to 29, that's a growth of plus 28. And then 29 down to -15, that's a change of -44. And 15 to 13, -15 up to 13, that's a change of 28 again. And 13 down to 7, that's a change of -20. So now here's what I want to do, is I want to compare these changes. Again, so I have this 7 compared to 28. -11 compared to -44. 7 compared to 28, -5 compared to 20. And what I start to notice is that this change from here to here is by a factor of 4. Like, all of my change is 4 times larger. That's my a value. That tells me that a is 4. So what I know so far, knowing that then, as far as my equation is concerned, is that g of x is 4 times f of x. And next thing I want to think about then is that h value. What is h? And h is how the x's are changing, the change in x from one to the next. So, clean this up a little bit and take a look at my change in my x values. And again, what I'm talking about in change of x values is the change this x to this x, here to here. How's x changing? And what I notice as I start to go from one x to the next x, it seems to always be +2. Yeah, it sure is. So that means that my h value is 2. H is 2. So that helps me out here, x minus 2. And then my last part to figure out, and this is the trickiest part, is k. And k is, an up and down translation. But it happens after a, after this stretch happens. So k is the change in y, or the outputs, same thing, after I stretch the thing by a, after I do the a multiplication. So I'm going to kind of clean this up a little ways. And what I want to do is I'm going to compare the change in the outputs after everything gets multiplied by the a value that I found. So, notice my a is 4. So what I'm going to do is I'm going to take this output, multiply it by 4, so times 4, and it gives me an 8. But what I wanted it to be was a 1. So I'll take this 9, multiply it by 4, that's 36, but I wanted it to be a 29. take this 5. I could do it with anything. I'm just grabbing them randomly. Multiply by 4. That's a 20. But I want it to be a 13. So what I'm starting to notice is, after I get these values, if I subtract 7 from them, I would get the G output. 36 minus 7, 20 minus 7 is 13. That's my K value. K is negative 7. So knowing that K is negative 7, boop, there it is. So here's my transformation on F. That gives me G. Notice this is a stretch. This is the change in the changes. There's my H. That's my changes in X. There's my K. That's my change in Y after I've already done the multiplication, after I've already done the stretching.